Hi, everyone. My name is Alon. I'm the CEO of SSV Labs, which is the core team behind both SSV and Compose. SSV has been around for quite a while. We're building a decentralized validator network, second largest on Ethereum, 5 million ETH staked, roughly 14% of Ethereum with amazing partners. And we've been doing it for the past 4 years. And so we're really good at building infrastructure. And Compose is this independent project we're building on top of SSV, which has the goal of connecting the different economic islands, as I call them, on Ethereum with something called synchronous composability. We actually, back in the day when we thought about scaling Ethereum, actually validators were supposed to be doing two things. One is securing Ethereum itself via staking, and two is actually facilitating something called sharding, which was kind of the original way of building, scaling Ethereum. Each shard is kind of a piece of the state of Ethereum, and within that, validators also facilitated interop, basically the ability to transact between those shards. But of course, that was proven to be very complicated. And so a few years ago, Vitalik and the EF decided to change a bit how we do things, and the rollup-centric roadmap was born. Rollups are very similar in some ways to shards, but they lack the native interop between them. And that kind of created fragmentation across the entire industry. Each rollup is its own economic island with its own distinct user set, validator, distinct users, dApps, and liquidity. And the result is that Ethereum is not one anymore. It doesn't feel like one big network. It feels like Ethereum and a bunch of different islands around it. Even though we are seeing a lot of attempts to create interoperability between rollups, it's not there yet. It doesn't really kind of achieve the goal of clear and frictionless composability between rollups. And that's kind of what we want to do at Compose. One of the solutions people we've been working on the past few years is asynchronous message passing. The idea is that we can use a set of oracles or some kind of a trusted party to send messages between rollups. You can think about sending messages as just calling another contract on another rollup. But that's proven to be not great because of latency. Latency, and also the fact that if you want to do something on another rollup and wait for a response, you kind of suffer twice because there's some latency in sending the message and some latency in receiving back an answer. And so for a user-centric dApps, it's not really feasible to do interop that way. Another approach, which is by far the most prominent one, are intents. Intents kind of flips the script around and says, let the user describe what they want to do, and some off-chain intermediary solvers will basically find a way to do that. And so the problem with that is that it heavily trusts and based on intermediaries and fronting liquidity for those types of intents. And the problem with that is that it's very limited. It's limited to the type of use cases we can do, mostly swaps and bridges. And also it's limited to the types of tokens it supports, because ultimately that intermediary needs to have liquidity in that specific token. Intents did improve significantly at UX. They are very crisp and still have latency of at least one block, but they're much faster than asynchronous message passing. With what we're doing, we're trying to introduce a new concept called synchronous composability, which is the idea that we want to bring the same type of transactions we are all used to on Ethereum, bring them to between rollups, meaning that those transactions can be, one, encapsulate a bunch of different interactions within a single transaction. They can execute in an atomic way, meaning that all of those interactions happen together or none of it happen at all. And thirdly, in a synchronous way, meaning that it happens in a single transaction, one interaction after the other. Those three properties are extremely important because they what substitute a transaction on Ethereum. And if we bring those types of properties into cross-chain transactions, then we call them synchronous composable. And that's really a powerful set of properties for the types of things we're doing on blockchains. And if we kind of need to compare between all of the different solutions, we currently either have slow but generic solutions which can do anything, or very fast but very specific solutions which are tailored for a very small amount of use cases. With Compose, we're trying to do both, be very fast but also very expressive and composable, and that's kind of the holy grail of interop, basically. And so Compose is consolidating liquidity users and dApps, makes it feel like you're just a part of Ethereum. Transactions just feel like you're just part of Ethereum, never left Ethereum. It's instant, meaning whenever the transaction hits the block, it's executed. And also there's ZK proofs that guarantee validity and atomicity. All of those things are Compose. And it's built on this concept called the shared publisher, which is basically a layer that takes ZK proofs from independent rollups, aggregates them, and prove them once on chain. The shared publisher is actually made out of SSV or Ethereum validators. So it's very decentralized and has the same trust assumptions as you would have on Ethereum itself, which is extremely important. And more so, each individual rollup has its own sequencer. We're not compromising on the sequencer in order to do synchronous composability. But you can also notice that we're enabling integrating external rollups like Base, Arbitrum, Optimism, and Unichain. And it's all due to the architecture of how shared publishing works. So you basically will be able to do synchronous composable transactions, which in other words are just instant transactions between a Compose rollup and Base, Compose rollup and Arbitrum, et cetera, and this is really powerful. The building blocks to create Compose start with the mailbox. The mailbox is just a simple contract where messages are populated. So when you want to move messages between rollups, they go into the outbox. And if you want to receive messages, they go into the inbox. The way they actually work behind the scenes is that those sequencers are simulating the transaction and pre-populating it with the right messages according to the simulation. So by the time you execute, the execution feels synchronous and as if you never left that specific rollup. That's what makes it so instant and incredible, is because everything already was simulated and you just need to pull the trigger and execute. And that happens between the sequencers. And so from a high level, each rollup has its own sequencer. They simulate a transaction and produce blocks and ZK proofs for those blocks and publish them through the shared publisher. The shared publisher actually wraps that up in what we call a super block. It checks the validity of each individual rollup through ZK proofs, but also checks the validity of the mailboxes and publishes it to Ethereum, meaning that you only publish once, but you can finalize a bunch of different rollups at once. So it cuts down significantly the costs. Synchronous composability is so big and so revolutionary that it opens up the door for many more use cases than we're used to with Interop today. First off, even the basic use cases like bridging and swaps do not require any intermediaries. It's literally just a transaction between rollups. It's extremely important. No intermediaries mean that you can do with any rollup, any token, and you don't depend on a third party to provide services. But then you have a bunch of different things which are not possible today, like cross-chain flash loans. Imagine taking a flash loan on one rollup and using the assets on another and then covering that loan. You can do atomic arbitrage, which is critical for the optimization and just efficiency of markets. Imagine developers can just do arbitrary read and write between rollups as if they're on one big chain. And ultimately, it also completely changes how dApp developers are deploying their dApps, because with synchronous composability, you only really need to deploy your dApp once into one rollup. And because it's synchronous composable with other rollups, other users can simply interact with it. They don't need anything else. They don't need intermediaries, and it's completely instant. And so all of those things are critical because they make the things you can do between rollups and later on between Ethereum and those rollups completely seamless. And if they're seamless, we're connecting Ethereum back again, and the UX feels just like magic. And so we've been working on synchronous composability for quite a while. We're just about to launch the first testnet for Compose, which will showcase a lot of the use cases I've talked about. Throughout the kind of the rest of the year, we'll build an integration with Base. For the first time, you'll be able to do synchronous composable transactions between a Compose rollup and Base. And later in 2026, we'll be slowly releasing Compose to mainnet. And so if you want to learn more about Compose, Interop, and Just Chat, we have a cool event today at 7 p.m. You're more than welcome to join. Drinks and just technical discussions and just discussions in general about the future of Ethereum. So I would love to see everyone. Just hit the QR code and I'll see you there. Thank you so much. I don't know if we have time for some Q&A. I don't know if anyone has any questions. Yeah.
It's So I'm wondering about where you draw the line between synchrony and atomicity,
Right.
and your definitions.
So there's different, essentially different properties, right? Atomicity. So let's start with synchronicity. It's easier. Synchronicity is the idea that you execute in one transaction, right? So that's kind of the smallest building block of synchronicity. In some ways, you can also say in one block, but I'm even more kind of conservative and saying in one transaction. That's synchronicity. And so if you add composability to synchronicity, that means that you can do a bunch of different interactions in a single transaction. Atomicity means that you guarantee the execution on both ends of the rollup, so rollup A and rollup B, either together or not at all. So you could have theoretically synchronicity and composability without atomicity. That's not great because then you can have things like double spend, right? You can have composability without synchrony. That's asynchronous message passing. You can have asynchronicity with atomicity. That's intents. Intents are atomic, meaning you either do or don't do, but they're completely asynchronous. But the holy grail is, at least as I see it, is all three together, because that's kind of the experience you're used to in Ethereum. When you, for example, trade on Uniswap on Ethereum, you're actually making a bunch of different smaller interactions within it, right? You're moving your assets into Uniswap, you actually swap, charge some fee, and then return those assets back to your EOA or contract. So atomicity is key there, because you don't want to, for example, deposit to Uniswap but not get your swap back, right? Or even worse, you don't want to get the tokens you swapped but the deposit cancels. And so all three are basically what Ethereum is today, and we want to extend that to whoever is settling on Ethereum, which are the rollups themselves. Anyone else? Cool, thank you so much.